Hello everyone, let's solve this integral right here. Now, we can't use partial fraction method to solve this integral right here, and this type of integral is, well, looks like a partial fraction kind of integral, but we're not allowed to use it here. So what we'll do is we will use substitution method. We see x minus 1 whole square and x minus 2 whole cube. Now, it would be kind of nice if this x minus 1 was somehow turned into x minus 2, because then we would just simply have x minus 2 12 to the power 5. So all we do is substitute x minus 1 as u x minus 2. So u is equals to x minus 1 by x minus 2, and now we'll find du. So du will be differentiating this, which is first the denominator is x minus 2 whole square, x minus 2 into derivative of this is, well, simply 1 minus x minus 1 into derivative of x minus 2 is just 1 again. So from here we get x minus 2 minus x plus 1. X and x cancels, so we just have minus 1. So that means du. So here we have dx because we differentiated with respect to x. So overall we'll get minus 1 by x minus 2 whole square dx. So simply dx is equals to minus x minus 2 whole square du. Now, for this type of integral or these types of integrals, not only will you have to find u, but you'll have to find x. And here, once you find x, you don't have to find dx because, well, we already have it right here. So from this equation, we get, well, no, let's use this equation. This will be easier. We'll get ux minus 2u equals to x minus 1. And we want to just have x, so this becomes ux minus x equals to 2u minus 1. And now from here we can take x common, that becomes u minus 1 equals to 2u minus 1. So x equals to 2u minus 1 by u minus 1. Right over here. Now I will have to rub these two eventually, but I'll keep it in a corner right here. So first, u is equals to x minus 1 by x minus 2. Dx is equals to minus x minus 2 whole square du. And x is equals to 2u minus 1 by u minus 1. Now, from these, we can solve this integral. Now, first, well, also we have a fourth one, which is the original substitution, which was x minus 1 is equals to u x minus 2. Now, if we let x minus 1, or simply put this value over here, we'll get u square x minus 2 whole square into x minus 2 whole cube dx. And this becomes u square x minus 2 to the power 5 dx. Now in this step, we'll have to substitute the value of x right here, so that we get this integral in terms of u, and also this dx in terms of du as well. And here, you could have just substituted dx over here, but it would have been kind of, well, I guess, kind of time wasting to write this over and over again. So instead, I'm just going to write it in this step over here. In fact, you don't even have to write it in this step actually, because first you would have to compute the inside the bracket of this whole to the power 5. And oh, actually, let's not substitute right away, because here we have x minus 2 and we have x minus 2 as well. Now, from indices, this becomes, well, x minus 2 to the power 5 minus 2. This is just simply 3. u square x minus 2 whole cube. So finally we get minus du by u square 2u minus 1 u minus 1 minus 2 whole cube. So this is equals to corner right here, minus du. In fact, I like to keep the minus outside, so minus integration of du by u square. So here this becomes minus 2u plus 2, and 2u minus 2u cancels, minus 1 plus 2 is plus 1. So we simply get 1 by u minus 1 whole cube, right? And here what we can do is, well, we can simply put this u minus 1 whole cube up here, because this is the same as u square by u minus 1 whole cube. So this is just u minus 1 whole cube by u square du. And here what we can do is, well, there are two ways to solve this, but it's kind of the same process. One, you can keep the minus inside the bracket and change it to 1 minus u whole cube, or you can just solve it right away and in the end multiply the minus with the answer. So in fact, I'll just do it right away. So all you have to do is expand u minus 1 whole cube right here. So this is u cube minus 3u square into 1 plus 3u into 1 square minus 1 cube by u square du. So let's just solve this integral, because here we can just separate these four terms right here. So this is the integration of u cube by u square, which is u square by 2, minus, they both have u square, so this is just 3, integration of 3, which is 3u, plus this is 3 by u integration, which is just 3 log natural of u, minus 1 by u square. So that means we get minus, or just the integration of u to the power minus 2. So we get u to the power minus 2 plus 1 by minus 2 plus 1 minus, and here minus 2 plus 1 is just minus 1, minus minus cancels, and we will get u to the power minus 1, which is just 1 by u. So this is in fact just 1 by u, and of course the plus c. Now at the same time we can put the value of u in terms of y. So this is, I'll write 1 by 2 outside, u square, which is x minus 1 by x minus 2 whole square, minus 3 into u, which is x minus 1 by x minus 2, plus 3 log natural of u, which is x minus 1, x minus 2, plus 1 by u, which is, well, simply changing the order of numerator and denominator, which is x minus 2 by x minus 1. Wait, I forgot to multiply the minus. Right. And then plus c, because here minus a constant is just another constant, and that is our answer, I hope. Let me check. Yes, indeed, this is the answer right over here. A bit long, but all you have to do is know the first step, and then after all it will be a cakewalk. So if you learn something new, please like and subscribe. Thank you. Oops.